And on to question 23 of the AMC. How many 4-digit numbers have all the three of the following properties? The tens digit and the ones digit are both 9. The number is 1 less than a perfect square, and the number is the product of exactly 2 prime numbers. Okay, so first, if you have a 4-digit number and the tens and ones digits are both 9, it's going to look something like this. And cool thing is, actually, 10 squared is equal to 100, right? And 10 squared minus 1 is 99. That satisfies condition 2. The number is 1 less than a perfect square, and actually, anything, like let this squiggly line represent any number, anything with a 0 squared minus 1 is always going to be something 99. It's always going to end in 99, right? So, and finally, we can write this expression as x squared minus 1. And we can factorize this, actually. We can make that x plus 1 times x minus 1. And why are we factorizing it? To make sure it's going to help us check the third condition. You'll see how all that works in a minute. Basically, all we got to do is trial and error. This is the main thing we're trying to satisfy. Okay? We tried 10, so 10 squared is not going to work because it's a 2-digit number, a 3-digit number, sorry. But 10 squared minus 1 is a 2-digit number. 20 squared is 400, minus 1 is 399, that's still a 3-digit, I need it to be 4-digit. 30 squared is 900, 900 minus 1 is 899, that's still a 3-digit, so we got to start at 40 squared. 40 squared minus 1 is going to be our first 4-digit number, which is going to be 1599. 40 squared is 1600, so yeah. Okay, so this satisfies condition 1. Condition 2 it also satisfied. We just need to check condition 3. In this case, x is 40, right? 40 plus 1, this is equal to 41 times 39. And I know for a fact that 39 is not a prime number. It needs to be the product of exactly 2 prime numbers. So I can eliminate 40 squared. Let's try 50. 50 squared minus 1 gives us 2,499, which is equal to 51 times 49. And actually, both of these are not prime numbers. 49 is 7 squared and 51 is divisible by 3. So no, 50 won't work. If I try 60, 60 squared is 3,600 minus 1, 3,599, which is equal to 61 times 59. And are these prime numbers? They look like prime numbers to me. Yeah, okay, these are prime numbers. We got a first working solution. 60 is a possible answer. We're just going to keep going all the way up until 100. Up until 90, sorry. I'm running out of space. Let's go over here. 70, that gives us 7 times 7 is 49, 4900, 4899 is equal to 71 times 69. 69 is divisible by 3, so that won't work. So if I go for 80, I don't even need to calculate what 80 squared minus 1 is. 80 is just 81 times 79. And are these both prime numbers? No, 9 times 9 is 81. 90, finally. 90 is equal to 91 times 89. And actually 91 is divisible by 7. So there's only one working solution, that's 60. So only one 4-digit number satisfies these conditions. That's 359, and only one satisfies. So my answer is B.